Good morning, everybody. Today's topic is radiation mechanism of a two-wire transmission system. And this is a conductor. This has two wires. This is the first wire and this is the second wire. So let's have a recap on some basic concepts of electric field lines or the electric lines of force. And this electric field line is created if the charge exists, and this line starts at positive charge and ends at negative charge. And for the second case, it starts at positive charge and ends at infinity. For the third case, it starts at infinity and ends at negative charge. And for the last case, it forms closed loops, neither starting nor ending on any charge. Similarly, for the magnetic lines of force or magnetic field lines, there would be no magnetic charges. And if you have any current carrying conductor, then these lines will be generated and they are encircling the conductor. Okay, this is a basic concept about the magnetic field line and the electric field line. Now, here we have the complete two-wire transmission line radiation mechanism system. So, this consists of four sections. The first one is the AC source or supply section. Second one is the two-wire transmission line. The third section is the antenna section, and the last is the free space. Okay. Now we'll see one by one, and in this first section you have the AC source. So it acts as the supply and it supplies electrical energy, and this particular signal has its own frequency and magnitude. Depending on this frequency and the magnitude, you will have the generation of the electric field. So that electric field is created because of the supply. Now we go to the second section. This is the two-wire conduction or conductor, or this is the two-wire transmission line. So because of the sinusoidal nature of the voltage, the electric field which is generated in this conductor or the transmission line is also sinusoidal in nature. And the electric field intensity depends on the magnitude of the signal applied, and it gives the number of lines or the density, the bunching. For example, here we have 5 lines drawn. Okay, so this density or this bunching of the lines depends on the electric field intensity, and the direction of the electric lines are shown by the arrows. And initially they have the downward direction, after that they have the upward direction. And here we already know that this particular electric line starts from this positive charge and ends at the negative charge. Then again starts from the positive charge, ends at the negative charge. So this happens during the positive half cycle of this supplied voltage, means during the negative half cycle, this electric field lines reverse their direction. Okay, so you have the orientation like this, and this repeats for the alternate half cycles. And because of this time varying electric field, you will get the current generated in the conductor. We know that this electric lines of force act on the free electrons and they displace them. Okay, displacement of electrons lead to the creation of current. When the current is generated, automatically it creates a magnetic field. Because of this magnetic field, we will have the magnetic lines of force. So there will be two fields. One is the electric field, the another one is the magnetic field. Both are time varying, right? So because of that time varying electric field and the magnetic field, you will get the electromagnetic waves generated, and this electromagnetic waves enters into the antenna section. Now we go for the third section. This third section is actually the extension of the transmission line, but this is spreading out. This is the flaring section. Okay, so it extends like this, and this section acts as the antenna section. And through this section the EM waves travels, and what happens, the changes here are The electric lines are now curved in shape, okay, and they are extending outward and they are curved in nature. So at the dead end of this antenna or at the opening of the antenna, this particular curved lines escape into the air. Okay. So now we enter into the fourth section. This is the free space. And at the free space, we have the electromagnetic waves, and here this electric field lines, they join to form the closed loops. And these phase waves are also periodic and they travel in the free space with the velocity of with the speed of light. And here if you take a point P naught here, and it is a constant phase point and it is moving outward and it reaches the point P1. After some time it reaches the point P2. Okay, and if you take the distance and if you measure the distance between this constant phase point P0 and P1, it is equal to lambda by 2, where lambda is the wavelength. Okay, that depends on the frequency, isn't it? So, and the time taken to cover the distance from P0 to P1 is T by 2, half the time period of the signal. Okay. So, in the full time period, it reaches this P2 point. So, from P0 to P2, it travels a distance of lambda and it is being covered within the time frame of T. Okay, and you will be having this closed loop formation and this spreads out further like this. Okay, so initially if you have, once again they are creating at another point, you have the formation of loop like this, again you have the curved loops like this, so it is spreading out at a far distance. If you see, you will be having the parallel lines, almost straight lines. Okay, initially they appear as the curved lines, at a far distance they become parallel straight lines. We have an analogy of free space wave with the water waves. Here you have a stone or a pebble which creates a disturbance in the pond, okay, or the water. So you will have the water waves generated or created, and that water waves, they travel and exist even if that disturbance is no more. Okay, so only one time you are throwing the stone, because of that one time the disturbance is caused and the waves are generated, and even if you are not throwing any more stones, the already generated wave travels. Okay, and if you throw some more stones, then the disturbance persists and new waves will be generated and they are also traveling. Okay, here this is similar to our EM waves. So here the disturbance is the electric source that excites the field and that generates the EM waves. If the electric source is removed, still that particular generated wave sustained and it travels. Okay. If you are continuously supplying, if the electric source is continuously supplying, then the new waves are generated and they travel. So here you see, this is the generation of water waves and they travel a long distance. So you will be having the straight wave front. Okay, these are water waves which can be seen at the sea. Okay, and they appear to be parallel straight lines. And continuously they are coming means you have the continuous disturbance there. So I hope that you might have understood the concept of EM wave generation and the radiation mechanism of a two-wire transmission line. Thank you.